Imagine a self-contained industrial city floating in the middle of the ocean, one that can process millions of barrels of crude oil, store it, and ship it out to the world, entirely cut off from the shore. This diagram illustrates the extreme scale of modern offshore energy. We are looking at an oil field located 200 kilometers from the nearest coastline, buried under 2,000 meters of water. You cannot build a traditional steel platform here. Those fixed structures rely on giant legs driven directly into the seabed, a design that becomes physically and financially impossible long before you reach a depth of 2 kilometers. Laying a subsea pipeline across hundreds of kilometers of uneven, deep ocean floor is equally impractical. The sheer cost of steel, installation, and maintenance would bankrupt the project before a single drop of oil was pumped. This is especially true for marginal fields. These are smaller oil reserves that might only produce for 5 to 7 years. You simply cannot justify spending billions of dollars on permanent infrastructure that will outlive the oil it was built to extract. So, if we can't build up from the ocean floor and we can't pipe across it, the engineering requires a completely different approach. Every piece of equipment, from the wellhead connection to the final export terminal, has to be mounted on a single, mobile surface vessel. That surface vessel is the FPSO. The acronym stands for Floating Production, Storage, and Offloading. These are true megastructures. To give you a sense of scale, look at the size of the 4 tugboats maneuvering this hull into position. As this schematic shows, the FPSO operates as a massive, unified system. It integrates a seaworthy marine vessel, a complex chemical refinery, and a high-capacity export terminal into a single asset. The first engineering challenge is position. An FPSO has to stay anchored directly above its subsea wells for up to 25 years, absorbing the full force of rogue waves and hurricane-force winds, all without breaking its connection to the seafloor. This diagram illustrates the internal turret mooring system, a massive anchor built into the hull's moon pool. While anchored to the seabed, giant bearings allow the ship to rotate freely. This lets the vessel weather vane into oncoming waves, minimizing hull stress. This schematic details the fluid transfer. Because the turret remains stationary relative to the seafloor, flexible pipes called risers can carry raw crude up from the wellhead, through the turret, and into the ship's rotating processing plant above. The turret mooring system creates a permanent, flexible grip on the ocean floor. It protects the fragile pipework from snapping, while allowing the enormous ship to ride out the worst weather the ocean can produce. Once the crude reaches the deck, it enters the topsides. These are the dense, modular processing packages elevated above the main deck. Topside separators process the turbulent well fluid, splitting it into 3 streams: oil, gas, and water. Gas powers onboard turbines or is pumped back down to maintain well pressure. Produced water is treated, then safely discharged overboard or re-injected underground. By processing everything directly over the wellhead, these topside modules act as a fully self-reliant chemical plant. There is zero need to transport useless water or untreated gas hundreds of miles to a refinery on land. Beneath the processing plant sits the hull. This provides the buoyant chassis for the entire operation, whether purpose-built or converted from an existing oil tanker. As you can see in this cross-section, the internal volume is dedicated to a massive grid of cargo and ballast tanks. A modern FPSO can safely store up to 3 million barrels of stabilized crude oil right inside the hull. Once tanks are full, offloading begins. A shuttle tanker pulls alongside or behind, transferring the crude directly via a heavy-duty floating hose. This massive onboard storage capacity, paired with a reliable ship-to-ship offloading system, completely eliminates the need to build a pipeline to shore. By combining the anchoring capability of the turret, the processing power of the topsides, and the storage capacity of the hull, the FPSO has dominated deepwater oil production for over 4 decades. This map shows the current global footprint. Today, there are more than 200 FPSOs deployed across the world's most demanding offshore environments, including the North Sea, the coast of Brazil, and West Africa. To understand exactly how these pieces fit together, this course will break down every major system. Modules 1 through 5 cover the structural design of the hull, the complex gathering and mooring systems, the strict maritime regulations, and the safe handling of liquid cargo. Then, modules 6 through 12 dive into the heavy engineering, the topside process piping, high-pressure gas compression, fire protection, and the critical life-saving appliances that keep the crew safe. Mastering this megastructure provides a complete picture of modern offshore engineering. If you're ready to start, hit subscribe so you don't miss a lesson. Drop a comment below telling me where you're watching from, and I will see you in Module 1, where we dive into the hull.